This question relies on your understanding of Hess's law, which states that in order to determine the enthalpy, the change in enthalpy for a chemical reaction, then we can use the enthalpy of formation of each individual component to calculate it. And Hess's law's equation is the delta H of the reaction, in other words, the change in the enthalpy of the reaction, is equal to the sum, and this capital sigma in Greek stands for the sum of the enthalpy of formation of the products minus the enthalpy, the sum of the enthalpy of formation of the reactants. And you were provided with a table of enthalpy of formation for various different chemicals. Another thing that we need to be cognizant of is maintaining the physical state when performing our calculations, because there is a different enthalpy of formation for water as a gas, in other words steam, versus water as a liquid, versus water as a solid or ice. And because of that, you need to make sure that you match up the physical states, which is why it's so important that we always write out the physical states in parentheses in chemical equations. So in your table that you were provided, what you can see is that the enthalpy of formation for carbon monoxide, or CO, as a gas is given to you with a value of negative 110.5 kilojoules per mole. And this per mole is important because we're going to use our stoichiometric coefficients in order to figure out how many we're actually using. So what you should notice is that in your table you were not provided a value for the enthalpy of formation of hydrogen gas. And this is because the standard state of a molecule always has an enthalpy of formation of 0. So for most diatomic gaseous molecules, like H2 or oxygen, which is O2, or fluorine gas, which is F2, in their gaseous state, that's their standard state. That's how they exist in nature. And those values for enthalpy of formation are actually 0. So the enthalpy of formation of H2 gas is 0, which is why it wasn't in your table. Those are things that you should commit to memory. What you can also find in your table are different values for C2H5OH, one for the liquid and one for the gas. And we need to use the one for the gas as given in our chemical equation. So for that value, you would find negative 235.1 kilojoule per mole. And then finally, for water, but in the gaseous state, you would find a value of negative 241.8 kilojoules per mole. Again, it's the negative 241.8 kilojoules per mole and not the negative 285.8 kilojoules per mole that is the enthalpy of formation for water as a liquid. So now we can just plug into our Hess's law equation by identifying which are the products, and that's on the right-hand side of this arrow, and which are the reactants, which are on the left-hand side of the arrow. In order to calculate our enthalpy, our change in enthalpy for the entire reaction, remember it's going to be the sum of the products, in other words, we're going to add these up, minus the sum of the reactants, taking into account how many moles of each we have. And this you can do by reading a chemical equation properly. And the way that you would read this particular chemical equation is by saying 2 moles of CO plus 4 moles of H2 react to form 1 mole of C2H5OH and 1 mole of H2O. Remember, the 1 stoichiometric coefficient is often omitted in chemical equations. So when we do our summation, which is the sum of, we need to take into account the number of moles. So in this version, when we look for the products, we know that there's only 1 mole of C2H5OH, which we can multiply by its enthalpy of formation, which is negative 235.1 kilojoules per mole, And you should notice that our moles are going to cancel out. And then remember, it's the sum of the products. So on both of these, we need to add them together. So again, you're going to have 1 mole of water multiplied by its enthalpy of formation, which is negative 241.8 kilojoules per mole. And the moles, again, cancel out. And this, you subtract the product, the sum of the enthalpy of formation of the reactants. And again, that's on the left-hand side. One of them is easy because H2 gas is 0. So we only need to consider the fact that we have 2 moles of our CO, which is going to be negative 110.5 kilojoules per mole. And notice that our moles cancel out. So now let's simplify this and break it down into its component parts. So again, we're still calculating our enthalpy of the reaction, our change in the enthalpy of the reaction. 1 times this value is just going to be that value. 1 times this value is just going to be that value. And if you break that down, what you would find is that you end up with negative 476.9 kilojoules, and that's from adding these two values together. Negative 235.1 plus negative 241.8 gives you a value of negative 476.9 kilojoules. And then we're going to subtract this value. And because we have two negatives, that's going to leave us with a positive. So we're going to be adding, because you have negative 2 times negative 110.5. You're going to end up with a positive value of 221 kilojoules. And again, that's negative 2 times negative 110.5. Now, when we add these together, we get a final value for our change in the enthalpy of our entire reaction of negative 255.9 kilojoules. And this tells us the enthalpy of the reaction of 2 moles of carbon monoxide plus 4 moles of H2 gas plus creating 1 mole of C2H5OH gas and 1 mole of water as steam or gas.